heavily that I did not tell you. All right, yes. Yeah, you got a solution? All right, let's do it.
So for the top, 34 plus 56. And for the bottom, 2 plus 178.
Okay, check it out. So here's how I'm going to check it real quick in my head. 6 and 4 makes 10. 30 and 50 makes 80. So 80 and 10 makes 90. That works out. 8 and 2 makes 10. That's 170 plus 0. So 170 plus 10 is 180. This works. Well done. What up? So this works. So we have a solution. Nice job. How'd you go about finding it?
I noticed that the 1 would have to be at the bottom and the... Yep, I noticed that would always have to be there.
All right, we have a conjecture. Mitchell says the 1 has to always go there. Now, I can very easily tell you that the 2 doesn't go there. Why can't the 2 go there, Mitchell?
Because
Mitchell.
it's addition.
Because addition. We have 200. We're never going to get to 180, right, if we started at 200. Same thing with 300, 400, 500, 600, etc. But what about a 0 there? Ah. So it's either a 0 or a 1 that has to go here. Put it away. 0 or 1 that has to go here. Can a 0 go there? We've proven that a 1 can.
Yes.
But can a 0? Let's find out.
Yes. Yes. It can. Because... Why? Wait.
So if a 0's there.
Oh, I thought you were talking about where the 7 is.
Nope, but now you know, right? So if a 0's there,
Nope.
can we solve it?
90 and 90.
90 and 90 would work, but we can't repeat 90s.
99 and 81.
What about 99 and 81, you said? Well, that requires 2 9s. What about maybe something like 87 and... Well, let's not do 87. Let's do 57 and... Nope, that's not going to work.
94.
Any possible solutions? What do we know about this spot right here?
It needs to be high.
If that's a 0, that needs to be high, right? What if it was a 6? Would that work? We'd have 60-something plus 90-something at most. It's going to get us 150. It's not going to be enough. What if we had a 7 here? Well, it's going to be 7 and maybe a 9. That would only get us up to 16, right? If I had an 8 here, I could have a 9 there, and that would work, right?
No.
No, why not?
Because it'd be a 17.
But yeah, I could have extra numbers here to boost it up, right?
Right.
What up?
Freshmen, you guys.
Does this count? Yeah. This count as yellow.
It's good enough.
Yeah, this is good enough. It's like a highlighter. Yeah, this is highlighter yellow.
Okay.
I feel like this is bias, sending around a bunch of juniors to count the freshmen. Did they even write anything down? Because that's what I would do if I was them. Be like, oh, yep, none. All right, moving on.
Do you see it?
Seniors win every year.
Yeah, keep it. Hey,
Except it's rude.
Yes, we did.
It's so
Because
rude.
everybody else, all the other freshmen that don't have something on is added to the seniors.
Exactly.
What are we talking about?
It's so rude. Yeah. It's not fair at all.
Any of the freshmen that don't have some their class color gets added to the seniors.
Yeah.
Get added to the what? The
Seniors.
seniors.
That's why the seniors win everything.
Boring. All right, so if we have a 7 here, it's going to be 70-something, maybe 79 at most, right? And then we could have a 90 at most here. It's not going to be enough to get this, right? So this either has to be an 8 or a 9. So if that's a 0, that has to either be an 8 or a 9. Which do you want to pick? 9. All right. So we put a 9 there. Great. Now, if that's a 9, if we put a number here, we can't have another 9 there. So can't do 90 and 90. At most, it could be an 8 here. So let's try that. So what do you want to put here and there?
7 and 3.
3 and a 7. Why did you say 3 and 7?
Because that makes 10.
Because
I would like to talk at some point to someone other than you. Okay? Yes.
if it was a 1 or a 2, then there would have to be a 9 or an 8. That's what we
Okay, got it. So here's what he's saying. These numbers have to add up to 10. They have to. They have to add up to 10. Why do the 3 in these numbers here have to add up to 10? Because we added in a 0. Right? If they added up to 12, then we'd have a 2 here, right? If they add up to 14, we'd have a 4 there, right? We carry the 1, drop the 4, right? So these always had to add up to 10. So we haven't even gotten a solution, but we've learned something. Those always have to add up to 10. So 87 and 93 works here. Will it work with the numbers up here? Now let's see what numbers we have left. We've used 3, 7, 8, and 9, so we have 0 here to use. 1, 2, 4, 5, 6, 7, 8, 9, and that's it, right? So we have these numbers left over. We need numbers that add up to 10 there. Jace, go ahead. 6 and 4 is all we have, right? 6 and 4 have to go there. I know it's hard to see that, so I'll do this. Okay? Now we need numbers here. Well, that's 10. So what do these numbers have to add up to? 8. Because that's 10. We're going to have 80 left over. Those needs to be an 8 there in the tens column. So what numbers do we have that add up to 8? None, so we bust. We lose. It's okay. None left over. All right, so 8 and 9 have to go there or there. Cool. So what if we switch 7 and 3? Or change 7 and 3 out, right? We didn't have to do those. We need numbers that add up to 10. Give me numbers that add up to 10 that we have left over. We tried 7. We can't do 8. We can't do 9. What is 6? 6 and what? 6 and 4. Let's try that. Well, if there's 6 and 4 there, we added 7 and 3 back in, right? That's what was there before. I need numbers that add up to 10 here. So what has to go there? 7 and 3, right? Well, that's 10. We need numbers that add up to 8. We still don't have numbers that add up to 8, right? Okay. So I tried 6 and 4. I tried 7 and 3 here. What about 5? 5 and 5, so that doesn't work. Exactly. Can't do double 5s. What about 4? 4 and 6. We already did it. Order doesn't matter, right? That's another thing we've been learning. That the 6 versus 4 there versus 4 versus 6 there shouldn't make a difference, right? 8 and 2. We haven't done that. So let's try that. Oh, man, we can't do that. What about 9 and 1? Oh, we get... Do you see how the 0 can't go there? Because if the 0's there, that requires an 8 and a 9. Then we only have so many numbers left that get us 10, right? 6 and 4 doesn't work. We tried it. 7 and 3 doesn't work. We tried it. 8 and 2 can't do it. 9 and 1 can't do it. So 0 can't go there. So we have a theorem. We're going to call it the Mitchell Theorem. Instead of saying 0 can't go there, how about we say what can go there? What's the only number that can go there? 1. 2 doesn't work because 200, right? 3 doesn't work because 300, etc. 0 doesn't work. Seems like it might, but we just proved it doesn't. So Mitchell Theorem, okay? THM says the 1 must go in the hundreds column. I'm a bad math teacher. I don't know whether it's plural hundreds or if it's possessive. You know what I mean? Does the hundreds own the column? Or is it just that's where all your hundreds go, so it's plural? I don't know. So now we know that the 1 has to go in the hundreds column. So the real problem is this. And the 1 always has to go there. We also learned something about these guys. What did we learn about those guys? Add up to 10. In fact, these both have to add up to 10. Now, how many numbers do we have that add up to 10? After we have the 1 down, we have 2 and 8. We have 3 and 7. We have 4 and any others? 5 and 5 doesn't work. 6 and 4 is the same thing as 4 and 6. 9 and 1 doesn't work because we already have the 1. Next question. What do you notice about this?
We're all even. 1, 2, 3, 4, 5, 6, 7, 0.
What do you notice? Every single number but 9. Nice job. So 9 doesn't show up. Why?
Because 9's too big.
We already talked about it, right? Whose theorem was that? I believe it was Parker. Was it Mitchell or was it Parker that got it? That we can't use 9, right? We talked about this earlier. If we put a 9 here, well, we have to have a 1 there, right? Same thing here. If we put a 9 there, well, it doesn't work. Or was that my last class? We're going to go with it as the last class. Okay, what do we know about these two numbers? No, we did this in here. We just did it really briefly. Shion, these two numbers have to add up to what? 8. So can I put a 9 there? No, because it's already too big. These two numbers have to add up to what? That's 10. That's 100. 7, right? They got to be a 70. So that doesn't work. I can put a 9 there. 9 does not exist. It's impossible for 9 to be in this problem. It can't go here. It can't go there. It's because 1's stuck, right? So new theorem. I think it was Shion. We're going to go with Shion. Or Shion-Parker. Do a height. That sounds like a theorem. The Shion-Parker theorem. No 9s. No 9s. Not allowed. So the real problem is not 0 through 9, plot them wherever you want. It's 0 through 8, and 1 has to go there. And we only have so many options for these guys, right? So let's test them all. Let's test them all. So if I do 2 and 8 first, let's put a 2 here and an 8 there. Cool. What does that mean has to go here? They had to add up to 7, right? So what numbers do I have left over? Well, I've used 1 and 2, and I've used 8. So I've got 0, I've got 3, I've got 4, I've got 5, I've got 6, I've got 7, I've got 8, and 9 doesn't count. Now, I what? Already used 8. Thank you very much. If that has to add up to 7, what are the only two numbers? I have 2 sets of numbers I can try. 3 and 4 and 0 and 7. 2's already done. So let's try 3 and 4. Okay. Gone. I need numbers that add up to 10 up here. Uh-oh. Just blew it. So 3 and 4 can't go there. You blew it! So 0 and 7 must go here, right? Okay, 0 and 7 are gone. What numbers add up to 10 that I have left over? Just 6 and 4. I've got 3 and 5 left over. Do those add up to 8? Okay, I should probably have done that in a different color. Sorry, the peach is 7. The green is 8. So 3 and 5. We win. So do you see how just setting up these guys kind of forces you into what has to work? That's a really good observation. They have to be 10. So check it out. Bad news. Our last solution was this. What do you notice between the two solutions? The bottom is exactly the same. And the top is only different in one way. The 6 and 4 are switched. It's the same solution. Right? Could we call it a different one? Sure. But, like, what's the point? Right? It's like taking something and, like, being like, here's a pen. And there's a totally different pen. Right? No. It's the same thing. So we have the same solution again. That was with trying 2 and 8 down here. Now, when we did 2 and 8, it forced us. Right? It forced our hand. So that's the only solution with 2 and 8 here. If we did 2 and 8 up high, wouldn't that just mean 4 and 6 down low? Yeah. It would, right? So, again, the only solution with 2 and 8 in it is this guy. How many solutions are possible then? Well, there's 1 for 2 and 8. There could be 1 for this. Maybe 1 for that. So there's at least 3 solutions, right? Or I shouldn't say at least 3. There could be as few as 3, right? 1 for each of these guys. Let's try the rest. One has to go there. Okay, so we already did 2 and 8 down here. Our other possible answers are numbers that add to 10 are 3 and 7 and 4 and 6. All right, so what do you want to try next? 3 and 7, let's do it. 3 and 7 here. Now, these guys have to add up to what? They have to add up to 7, right? So our numbers that are left over, we've used 1. We haven't used 0. We haven't used 2. We've used 3. We haven't used 4. We haven't used 5. We haven't used 6. We haven't used 8. So which numbers are going to add up to 7? Do we have options? We only have one option. 2 and 5. That's what they add up to. I know what you mean. 2 and 5 add to 7. So they're gone. What has to go here again?
7.
Numbers that add up to?
8. No. 0.
10. You get us a 0 there. 10. So what numbers do I have left over? I only have one set of numbers that works.
4.
Do you see how this automatically locked us in? So there's only going to be one. If this works, there's only going to be one solution for 3, 7. So what has to go here now that's left over? I need numbers that add up to 8. Do I have numbers that add up to 8?
Yeah.
I do. 8 and 0. And again, I could switch the order. It doesn't matter. 0 versus 8, right? Same dumb thing. So now we just found the second solution. So we have solution number 2. Well, if there are more, they must stem from 4, 6. You know what I mean? They have to. So at minimum, if there is a solution for 4, 6, right? At minimum, we have 2 right now. But if there is a solution for 4, 6, then we have 3. But maybe there's more combinations. We'll have to see. So we have 2 of them. Let's go get 4, 6. See if there are any. All right, so here we go. We've got this and this adds to this, and that equals 90. We know that this has to have a 1 here, and that equals 180. We also know that these guys add up to 10. These guys add up to 8, and that these guys add up to 7. We only have one set of numbers that adds up to 10 that we haven't tried in the bottom. Again, trying them in the bottom is the same as trying them in the top, right? We showed that earlier, right? So, and it was 6 and 4. Doesn't matter which order we do them in. So let's put 6 here, 4 there. All right. Numbers we have left over. We've used 1. We have not used 0. We have not used 2. We have not used 3. We have not used 5. We have not used 7. We have not used 8. 9 doesn't count. Remember, no 9s. Give me numbers that add up to 7. How many options do we have?
1, 2.
How many numbers add up to 7 that you see here? 5 and 2, and 7 and 0. This is the first time we've had 2 options that add up to 7. Okay, so 5 and 2. Let's try that one. So 5 and 2. We need numbers that add up to 10. Do we have any? We only have 1. 3 and 7. 8 and 0. Now that feels familiar, because we have an 8 and a 0 there, and we had an 8 and a 0 last time. Is it the same?
No.
How do you know it's not the same?
Because it's close.
It's close, right? The 8 and the 0 switch spots, but the 3 and the 7 don't. Oh, wait, we have 3 and 7 there. We have 6 and 4 there. We've got 2 and 5 there. Is it the same, or is it not? What do you think?
It is, technically.
Do we consider that the same, or do we not? Why didn't we consider these the same?
Because they're so super.
Right, these are different. Why did we say those are different? Yeah, they have very little in common, right? We've got a 4 here and a 2 there. Oh, we've got 4, 2, and 3. Here we've got 5, 6, 7, 1. Just the 8 and the 0 switched. I think we're getting too loose with our definition of similarity. Because, yeah, they're all going to have numbers 0 through 8. The numbers are going to be moved around, right? So different or the same. We said we could switch these guys and it wouldn't change anything, right? These guys wouldn't change anything. But notice we have a switch that's different, right? We have... Oh, I'm sorry. No, it's exactly the same. Right? Totally. It's got to be, right? Somebody think for yourselves here. I'm tired of thinking for you. Is it the same or is it not? We said if you switch here and here, same crap, right? If you switch here and here, same crap. Is there a switch that happened between these two that isn't one of those? Meaning that would be different? The 6 and the 4 just moved down. The 7 and 3 just moved up, right? That's all that happened there. Is it the same? We said this was different. Do you see how the 2 switch with a 0? That's definitely different. So this is the same, right? All we did was just switch these guys. That's it. So the same. So let's try 6, 4 again, because remember we had options here. Try 6, 4 again. This time, we're going to, instead of putting 2 and 5 here, we're going to have a different option. What other option do we have from before? 7 and 0, right? Okay, so now what are we left with? Well, we're left with 3, 5, and 8, I believe, and 0. Nope, not 0. 2. Thank you very much, Shion. All right. What numbers have to go here? 8 and 2, because they have to add up to 10. Those have to add up to 8, right? So those are going to be our 3 and 5. Is that a unique solution? Let's compare. First off, let's compare it to the last one we just did. Elite level folding skills. Check this out. They said it couldn't be done. And we'll get rid of the bottom part so you're not distracted. Here we are. Are they different solutions or the same? Remember, our rule was we could switch top and bottom like that. We could flip-flop like this. Shion says they're different. Why do you think it's different? It's okay. It's hard to back that up. Yeah. Completely different spots. If I switch the 3 and the 7 with the 6 and the 4, do I get this? No, because 6 and 4 is down low, but 3 and 7 aren't up high. What if I flip the 3 and the 7? Well, no, I don't have a 3 or 7 in either of these spots, actually. Right? It's unique. So we've gone through and went through every possible numbers that add up to 10, right? And each one had a single solution. So we found all 3 unique solutions. That's dope, right? This is a stupid problem, right? Like, give me numbers that add up to 180, now give me numbers that add up to 90. And you can only do 0 through 9, right? It's not a very interesting problem. But when you break it down, something that simple can be really interesting. There's only 3 possible solutions. That's it. And we've proven it. Well done. Shion, you can take all of these, and if you want to cut them up or whatever you want to do, put them back on the mural, okay? Well done. Mitchell, if you want to put it back up there, go ahead. Or grab something else out of the box if you want, if you don't like that one because it's not that colorful. Just don't cover up anything cool. You know what you're doing? There's tape back there. If you need scissors, here's some scissors. You guys did such a great job, I won't even throw them at you. Here you go. That's right. Well done. Algebra, I want to talk to you about something. You're a bunch of freshmen in algebra, right? That was a geometry question, loosely. I mean, after you get past what the complementary means and all that, it's not really. You blew my geometry class out of the water today with this warm-up. Well done. Well done. I had one other class prove that there's only 3 possible solutions, but they didn't see that there was actually an overlap between one of them. Dang. Dang, son. Some days you aren't. But today, well done. Those of you that participated, congrats is earned. All right, so here's what we're going to do today. Let's take a look at some, let's first take a look at the homework, right? Here's the answer key. Trade and grade. Trade them. Who needs pens? Yes. Nice catch. Nice catch. Nice, almost catch. Nice catch. Nice, oh, almost. 1, 2, 3, 4, 5, 6. We got 6. Any more? Well, oh, you can keep that one. I found it on the ground. Huh? Oh, hit me. All right. Baseball. All right. Trade and grade, let's go. Get it out. Here's the answer key. Here's what I need to see, okay? I need to see the graph, and I need to see the set notation. We're going to learn a little bit extra notation today. Sorry, how about that? That better? How about a little more zoom zoom? That's dope, right? That's good. Pretty thick. All right. So here it is. J is between -15 and -10, non-inclusive. So we have open circles. It's in between, so it's colored in the middle. You smell what I'm stepping in? Cool. How did I get -15 and -10? Well, I divided by 4 to both sides. Remember, we do it to all the sides because there are 3 of them. The middle turns into j. The outsides turn into negative 15, negative 10. You smell what I'm stepping in? Yeah. Nope, closed circle means it's included, right? When we color the number line, it's saying where j is. Can j be negative 15 or negative 10? It can't be those. Remember, we only color where it is. And so the open circle means that's not where j can be. It's up to, but not including that, right? That's kind of the stopping point. So nope, needs to be open. Needs to be open. If j could be negative 15, then it would include negative 15, but it doesn't, right? It says j has to be greater than negative 15. Not greater than or equal to. Number 6, we multiply both sides. Again, when you deal with an OR equation, or I should say an inequality, you just deal with them both separately, right? So one of them you multiply by 4, and you get x is less than 9, or 36. The other one you multiply by 7, you get x is greater than 42. Or, you just deal with them separately, right? I hate calling that compound. I feel like that's cheating. Like, really, it's just two simple inequalities next to each other. But I guess they're talking about the same x, which does compound things, in my experience. Now, all these guys are within the real number system, right? So you don't need to write anything except like x or j or b or x, right? Today, when we go over a little bit of word problems, we're going to have some restrictions on that, right? Sometimes you can only talk about natural numbers. Yeah. The thingy? Oh, for number for those guys? Okay, let me get myself out of the way. We don't need this. Yep, the moneymaker. All right. How about that? Questions on 1 through 1, 6, 2, or 7, because those are the ones you can see. Okay. Because we're eagerly copying it down, which is a waste of everyone's time, including mine.
Why?
Because, like, it doesn't matter. Like, have you caught in yet? Caught on? Like, yeah, it's for your feedback. Right, right. Well, I mean, I don't know why, but, like,
Well, what do I do then? Just turn it in,
you can do that, yeah.
turn it in.
No, what I would do is I would just, like, learn it. And if you feel like you've learned it, then you're good. Yeah.
For number 7 in the set notation, let the x be s since s is the variable.
Yes, it is. So, my bad. I wrote x instead of s. Good call.
I gotta ask him something. So if I turn it in like how it is, when I have it wrong,
Probably.
then does that not get it back graded?
No, what would happen is that I would not grade that specifically unless I really want to go back through and look through it. So if you feel like super nervous about that, great for you.
Fine about it. It's just I got
But like, I just want to make sure you guys know this so you guys can like actually know your crap, right? And how do I check to see if you actually know it? The quizzes. I used to make homework completely optional, where I'd be like, "There's some worksheets back there if you want to do it, and if you have any questions, bring it to me," right?
So I don't like if I turn it in, I won't get it back graded.
No.
That's it.
All you guys are like, "Oh, I'm gonna secretly write stuff down while it's going." It's like, just stop wasting your time.
I wasn't sick of it.
Learn. I know you're not, right? But other people from other classes, and some in this class, are like thinking they're being so clever. And it's like, dude, I freaking know. I made the system. All right.
You made the cheater system.
Like, I designed it that way on purpose. I don't want homework to be a punishment. I want it to be something that you learn from. And if you're not learning from it, then it's a waste of everybody's time. Why do I make homework assignments so short? Because if I made them really long and you already know how to do it, then it's a waste of your time, right? And if you don't know how to do it and I made them really long, then it's just beating you into the ground,
What about story problems?
right? Oh, story problems. We're going to learn about those today.
Yay! Why'd you ask?
No, like, that's something we need to do. Because, like, they aren't hard and you need to get over it. And the reason you guys can't do it is because you never know what the math actually means. And so that's why when you put words to it, you're like, I don't see the connection. It's actually not hard if you know what it means. Again, why are we going over this? So you can get feedback. Is this drastically different than what you have? And if it is drastically different, do you know why? And if you don't, raise your hand and ask. That's what this time is for. Don't copy it all down. It's a waste of ink and time. Look at what I have here and see if you can make sense of it. Look at number 8. I divided by 7 here. I subtracted from 4 there. I just dealt with them separately, right? So W is going to be less than 3. That's going to be W greater than 6. It's an OR statement, so of course it's going to go to the left and the right. Here's 3, there's 6. Done. These guys. Divide by 7 here. All sides. I get negative 17 and negative 12. Sorry for the big numbers. 0 divided by 7 is just 0. 22 divided by 2 is 11. So 0 and 11 are my restrictions, right? It's going to be closed. And it's an OR statement, so it's going to the left or the right. I don't even need to look at the signs. It's OR. Otherwise, it would be AND. Here I goofed on number 5, and I rewrote it down here. Open circles, right? It's an OR statement, so they go to the left and the right. That's it. New notation today. You ready?
Yeah.
They still don't get it. All right. Well, someday. So, new notation. You'll see this a lot of the times. So let's look at number 1, for instance. Here's number 1. That's what we wrote. That's the set notation, right? There's another way to write this, okay? Both are non-inclusive. So we write this. Looks like a coordinate, but it's not. Okay? This is telling you the range. It's between negative 15 and 10. Negative 10. It's non-inclusive, so the brackets look like that. Now, if I did this, then that would change things, and now we use this. That's it. It's not a coordinate. It's just this. It doesn't specify for what variable, so that kind of sucks. But this is non-inclusive. This is if the line's underneath. Inclusive. My bad. Let me zoom out. That's it. Can you handle it? Now, question. What if it says something like this? J is greater than 10. Well, here's the problem. Before we had 2 numbers to write, right? So now we have greater than 10. So starting at 10 and growing off to infinity, right? My bad. There you go. Positive infinity. Heading off to positive. It starts on the left side. Remember, smaller number always goes on the left. And heading off to positive infinity. Now, if I did this, that would change this bracket because it includes 10. Can you ever include infinity? No, because you'll never get there. So this is always curvy bracket for infinity.
Curvy bracket?
Yeah, you know, like the regular parenthesis. Yeah. Yes, sir.
What if infinity is minus infinity?
Infinity and minus infinity, you can't subtract ideas.
Want to be 0?
Nope. You can't subtract ideas. It's like saying bologna sandwich minus bologna sandwich.
It'd be 0.
All right. Let's talk about word problems real quick. Yes. In your notes. Yo. Oh, pens? Yep. Hit me. Oh, man. Too short. Nope. That was my bad. I went low. Ah, man. I'm trying to one hand. I got one. Nope. That's all right. He had a long throw. All right, here we go. Yes, but don't throw them. Thank you. That's right. Running with Scissors. Fantastic album. All right. Here we are. It says, Mr. Mack, that's me, is buying 12 shirts for math team. I've always wanted to make shirts for math team. They've never allowed me to. Can you imagine what I put on them? Because they're like, oh, yeah, right triangles, we're always right. And they're like, that's funny. I'm like, X in parentheses. We always practice. Why do we wrap things in parentheses? Yeah, okay. All right. Yeah, exactly, right? Right? Now, imagine Matt walking around with a math team shirt like that. Now that'd be great. Mr. Mack is buying 12 shirts for math team. First, he must buy blank t-shirts and then pay $2.75 for each shirt's logo. So he buys the t-shirts and then he pays extra for the logo. If Mr. Mack's budget is $99 Okay? How much money can he spend on each blank shirt? Write and solve an inequality to find the possible cost of each blank shirt. So this is like a real life problem that pops up. I got $99, right? Right? And I need to pay a certain amount for the logo, right? They'll print as many logos as I want, but I have to pay for the logo, right? It's $275. Now the question is, how nice of a shirt do I want to buy, right? Do I want to get cheap cotton? Do I want to get nice cotton? That's going to change the price of the shirt. So I'm trying to figure out how many I could buy, right, given a certain amount. So let B be the cost of a blank shirt. So I wrote out an equation. The cost of all the blank shirts plus $275 is the cost of a single blank shirt, right? Well, I want to buy 12 shirts. So that's the cost of one shirt, right? The quality cost plus the logo times 12. That's the cost of all 12. Now, my budget is up to and including $99. So it could be 99 equal exactly. That'd be an equation. But maybe I don't want to spend all that money, right? I need it less than or equal to 99. Yeah, maybe it doesn't come out exactly to 99, right? So I set up this inequality. My budget, 99, okay? This thing right here that I'm spending is going to be less than or equal to that, right? I'm not going to spend more than $99. Good Lord, right? I don't care about you guys that much. Although those shirts would be hilarious, okay? Imagine, just the front with that and on the back explaining what it means. Risque. Also looks like a hyperbole down there. So anyway, this thing. I distribute the 12. I get 12B here and 33 there. That's convenient. That worked out nicely. Why did I get 33 here? Let's do this in our head. Decimals suck. What's 2 times 12? 24. Pocket that. Pocket that. It's 24. Okay? 75. 0.75 is a fraction. 3/4. 12 times 3/4. 12 divided by 4 is, times 3 is, 9 plus 24 is. All that extra work because of decimals, but I could have done it in my head, right? Easier with fractions. All right, now I'm going to subtract 33 from both sides. Subtraction property of inequality. It goes away. I get 12B is less than or equal to 66. I divide. Now, do I need to flip the sign? No, why not? It's not negative. It's only when you divide or multiply by a negative. When I do that, I get 550. So every shirt, the quality of which, if I'm going to spend exactly to my budget, is going to be 550. If I want to spend less than that, it's all good, right? So now I need to go hunting for shirts that only cost 550 per piece, right, or less. That's the goal. So I can spend up to and including 550 per shirt, right? I'm going to need to find some great sales because shirts don't come that cheap. Let's be honest.
Yeah, for real.
For real. What up? Tucker, I'm digging the hat. Very nice.
Is that Tuck Tuck? Tuck Tuck. What up, G?
Yeah, you are a little bit, but it's all right. Come on in, Tucker. Friend of the pod, guest of the show. I got another one for you. All right. Lot of words. Again, I made these a long time ago. I don't fit as much on the page anymore. Let's zoom out. The Capitalist Chronicle charges a fee of $6.50 plus $80 per week. When I say per, what do I mean? Each week. So multiplication, right? So $80 times the number of weeks to run an ad. The People's Press charges $145 per week, so way cheaper per week. Or actually more expensive per week, right? 80 versus 145. As long as the product is union made, the people. But they don't charge you a flat fee. So they charge you $6.50 up front, $80 after that per week. They charge you $145 per week. No flat fee up front. For how many weeks must an ad run at the Capitalist Chronicle for the total cost to be less expensive than the cost of the other one? Let W be the number of weeks. So now the Capitalist Chronicle is $6.50 up front, $80 per week. You dig? That ain't no thing. People's Press, give me $145 per week. No flat fee, right? So cool, we're going to compare the two. Comparison. One side versus the other. We want to know for how many weeks must an ad run at the Capitalist Chronicle for the total of the cost to be less expensive than the People's Press. Here's People's Press. Here's this guy. We want to be less. See you next week. Tomorrow.
Next week.
Yeah, I know, right? It does. Yeah, I know. I try to catch it with one hand. Probably a kid in the back. I will be back later. See you, CJ.
See ya.
Good job today, Shion.